Welcome back. Chapter 7, Section 7.3 Areas under any normal curve. The focus points of this section are: compute the probability of standardized events, find a z-score from a given normal probability, that is, inverse normal. Use the inverse normal to solve guarantee problems. So let's see what these mean. Normal distribution areas. In many applied situations, the original normal curve is not the standard normal curve. Generally, there will not be a table of areas available for the original normal curve. This does not mean that we cannot find the probability that a measurement x will fall into an interval from A to B. What we must do is convert the original measurements x, A and B to z values. So I hope you understand. You see, we have a table for z scores. We don't have a table for any normal x scores. So we need to convert that x to z and then we can use the table. So the procedure, how to work with normal distributions. To find areas and probabilities for a random variable x that follows a normal distribution with mean mu and standard deviation sigma, first convert x to z values using this conversion formula. Z is x minus mu the whole over sigma. And then we use our table to find corresponding areas and probabilities. For example, so we are told x has a normal distribution with mean 10 sigma 2. Find the probability that an x value selected at random from this distribution is between 11 and 12. In other words, you want to find probability of those x values between 11 and 12. Now, since the probabilities correspond to areas under the distribution curve, we want to find the area under the x curve from the interval x equals 11 to x equals 14. So first we'll convert the x values to z values and then use our table. All right. So z conversion, right? X minus mu over sigma gives me z. So take my x. You see, x has limits of 11 and 14, right? So that gives you limits for z1. All right. So where did those 11 come from? Here, 11 and 14. So those are the limits for x. That's what we are using in our conversion. 11 and 14. So z1, one limit for z is here. Another limit for z is here. So now the point is to find, this is your original x. X has to sit between 11 and 14. We used our formula, converted everything to z, and you now have z between 0.5 to 2. Where did those 0.5 come from? Here. For 11, you get 0.5. For 14, you get 2. So you have converted the x to the z. That's what it is, okay? So 11 gave you 0.5, 14 gave you 2, and this blue region now becomes this blue region. Why would we convert? Because we have a table here. We don't have a table here. So this we will refer to the table. Use z equals 2, all right, and z equals 0.5 and subtract. Where did they get these numbers from? So let's look for the table. There you go. So when z is 2, 2.0, 0.9772, right? And when z is 0.5, here, okay, 0.50, 6915. All right. When you subtract the 2, you get this. All right. So the point of this is I can use table for z score but not for x. There is no table for x score. So this area is actually the same as this area. You have compressed it a little bit, made it taller, and it's the same area. So to find this area, it's sufficient to find this area. How do I find area between two numbers? Well, we use the table. Area to the left of bigger number minus area to the left of smaller number. That's what we did. And taking the difference, we get this. So the probability is 0.2857 that an x value selected at random from a normal distribution with mean 10, standard deviation 2 will lie between 11 and 14. Okay, so this is basically answering the question. Find the probability that an x value with mean 10, standard deviation 2 will lie between 11 and 14. So we have simply rewritten this, right? We have rewritten this, and that's your answer. All right. Inverse normal distribution. Sometimes we need to find z or x values that correspond to given area. So right now, so far, what have we been doing? Given an z value, we have been finding the area. Sometimes you want to find the z value given area, all right? That is going back. Now, the situation arises when we want to specify a guarantee period such that a given percentage of the products, of the total products produced by a company last at least as long as the duration of the guarantee period. In such case, we use the standard normal distribution table in reverse. When we look up an area and find the corresponding z value, we are using the inverse normal probability distribution. So let's see what that means, right? So here is a Magic Video Games Incorporated, which sells an expensive video games package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of the computer control system. The guarantee policy will refund the full purchase price if the computer fails within the guarantee period. Okay, research department has done tests to show that the mean is 30 months, standard deviation is 4 months. Okay, computer life is normally distributed. How long can the guarantee period be if the management does not want to refund the purchase price on more than 7% of the Magic videos? So 7% should be the area you're looking for, the probability you're looking for. Okay, so what should be that x value? So that x value is the guarantee period. These lifetimes fall short of the guarantee period, and anything beyond that x, these exceed the guarantee period. All right. If a computer system lasts fewer than the guarantee period, a full refund will have to be made. The lifetimes requiring a refund are in the shaded. This represents 7%. Now we can use the table to find the z value such that 7% of the total area under the standard curve lies to the left. Okay, so let's go back to the table. 7%. 7%, mind you, is the area. So this is 50 some odd percent. So you need 7 meaning 0.07 something, right? So that's a good one. So 7% will lie between these two numbers. You see, this is no, not that. I'm sorry, forgive me. So 7% should be here. There you go. 764, 749, 720. This is 0.7%, right? So it should lie somewhere here. So let's see what they do. So 7% should look like 700. This is 708. This is 694. So 7 is closer to this one. So let's see what they say. Right? So you're looking to find 700, 0.0700. So 0.0700 is between these two numbers. All right. So if this is closer to here, you see, if you think of $700, this is 6 less, this is 8 more. So that's closer. You choose that. So that's the Z value. Okay, closest area. To translate back, you got the Z value. Use this formula to get X back again. Z, standard deviation plus mean. All right. So interpretation, the company can guarantee the Magic Video Games package for 24 months. For this guarantee period, they expect the refund purchase price of no more than 7% of the video games package. All right. We'll continue in our next video. Until then, bye.